Hey guys, welcome to 2-5 Day 1 Ellipsis Notebook. So let's go ahead and do our warm-up for today, and here's our warm-up, okay? It says, complete the square to find the center, HK, and the radius of the circle if you have the following equation. Now notice you don't have a constant here, so it's just a 0. Step 1, we're going to combine our x values together. So remember to take half. Okay, half of -8 is -4 squared. So what you do to one side, you do to the other side. So there's your shortcut that you can do. Combine your y, so put a plus y. Half of 6 is 3. And we square it. What you do to one side, you do to the other. And then all you have to do is add those numbers together, just like so. Okay, here we go. Oh, let me see if I can do this one. Yeah, there you can see it. So turn this on. So we got 0 plus parentheses -4 squared. Make sure you have your parentheses. Plus parentheses 3 squared. And that comes out to be 25. Now, that is not the question it's asking you to find. It says do what? Find the center and the radius. Since you're looking for the center and the radius, the center, this is your h, this is your k. Remember, it's always opposite, so 4, -3. This right here is r squared, so r squared is equal to 25, so the radius, r, is equal to 5 units. Okay? So there's your center, and there's your units. All right, make sure you submit this online, your warm-up, please. Okay, today's goal. Now, keep in mind we're going to change a few things on here so you can kind of visually see it better, okay? So, today you're going to be able to write the equation and also graph your ellipse. All right. So, what you have done before is you have done a circle where we do a cross section right here. So when you do a cross section right here, you get a shape. When you look down, it looks like a circle. Well, today we're going to do a cross section going straight down, and when you do that, you get a shape. And a lot of us call that an oval shape. In math and in science, we call that an ellipse. Okay? All right. So let's go ahead and fill out our notes. Ellipse. What is an ellipse? An ellipse is a set of all points in a plane, the sum of whose distance from two fixed points is constant. When the sum, I guess I should add that word. When the sum of whose distance from two fixed points is constant. These fixed points is called a foci. Singular is focus. So we're going to talk a little bit about an ellipse, and foci, just want to mention it to tell you how it works, but we're not going to find it today, okay? It'll be another day. The origin is the center of an ellipse. Now, keep in mind, what else have you learned that also has a center? Do you remember your circle? A circle also has a center. All right. The equation of an ellipse whose x-intercept, or a0, and -a0, and y-intercept 0b and 0 -b comes from the following. A circle is a special case of an ellipse. So this is the formula that you guys are going to use, okay? But then I'm going to add a little bit as well. So now I want to talk about a circle. So you have x squared, okay, plus y squared is equal to r squared. There's your circle right there. Now, if I look at this, my center, h and k, is 0, 0, because I don't have an h and a k. Now let's change the number so I can tell you how they are related. So x squared equals y squared is equal to 9. All right. Notice how your ellipse has a 1 here. What can I do to make that a 1? Well, mathematically, you can divide everything by 9. Well, if you divide this by 9 to get a 1, you have to divide everything by 9. Did you guys see that? All right. So now it looks like this. So now my equation looks like this. So I have x squared over 9 plus y squared over 9 is equal to 1. You see how it looks like that? What do you notice about these two this a squared and b squared? They are exactly the same. Your radius is a 3. And that's why you have a picture. You go out 3, up 3, down 3, and you have a circle, okay? So that's where that comes from. An ellipse is like a circle where part of it is kind of flattened out a little bit more. It has a shorter distance to the center. All right, knowing that, I'm going to add a formula as well. This is where your h is 0 and your k is 0, okay? So I want you to add this to your formula. X minus h squared over a squared. You see how I have the h? Plus y minus k squared over b squared is equal to 1. This is the formula I want you guys to have, okay? So your center and all that will come into play. So make sure you copy down this formula instead. All right, so what are some real life uses for ellipse? Well, when a ray of light or sound emanates from one focus of an ellipse and it bounces off the ellipse, it passes through the other foci. This reflecting property is responsible for whispering galleries, and there is a ton of whispering galleries. You can look it up online. We got some in the United States. The U.S. Capitol has one, and then there's other places. The Grand Central Station in New York City has one. So here's an example. You notice the shape of the ceiling. Here, if I have a desk right here and the other person's right here, if I'm whispering, the other person can actually hear what I'm talking if I'm in a room shaped like that. So it's like sound bouncing. So some of it is like a whispering gallery. There's where you can use some real life. Another example, it would be John Quincy Adams. He was able to listen to his opponent's conversations because his desk was positioned at one of the foci beneath the ellipsoidal ceiling, and his opponents were located across the room at the other foci. Kind of like this room right here. So if his desk was here and his opponent was here, everything they whisper, he could hear. Okay? Alrighty. There is the rotunda, and there's John Quincy Adams. Another thing that in real life that we use ellipse for is your planet. Notice the path of the Earth around the sun is an ellipse. The sun is at one focus, and a point in the center is at the other, and that's why we have summer and winter, how far we are away from the sun, and the sun is the center. So we don't actually do a circular motion, okay? It's more ellipsoidal, but it's not like a true circle. All right. Another example, well, guess what this machine is called? This is an elliptical machine. Notice the shape it makes. And here's your bicycle. When you pedal, it makes an elliptical shape as well. So those are 4 examples. Make sure you list 2 of them in your notes. Okay. Well, graphing an ellipse. Now I'm going to change a few things here, and I need you guys to help me out, okay? This is actually step 2. So let's go ahead and add step 1. So what is step 1? Step 1 is find the center, okay? And your center is always going to be h and k. Step 2, take the square root of the denominator, that's the number on the bottom, and you're going to graph the positive and the negative of that number. Remember, x goes left and right, and y goes up and down, okay? And from there, you're going to get your vertices. Step 3, connect your vertices and co-vertices. Now, when you do this, kind of give it a curve, okay? Not an angle when you are connecting them. All right. And there you have that, okay? Ooh, I am missing a paper. Hang on just a moment. I'm going to do something real quick. All right, so let's go to your notes. It didn't print all that it was supposed to. So let me go to your notes instead, and we're going to do example from your notes. Okay, just directly from your notes. All right. So let's take a look at example 1. Here we go. My apologies, okay? That paper didn't print. Okay, so if I am going to graph this, let's go ahead and go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right. Make this a little bit bigger. There we go. Your center, notice your H and your K is 0 because you don't have an H and a K. So your center is 0. So I'm going to draw my center right there. Let me use a different color pen. Okay? Now, X, here's your A square. So A square is equal to 36. So what is A equal to? 6, because you have to take a square root. Notice your X goes left and right. So X, I'm going to go 6. 1, let me use a different color pen. 1, 2, 3, 4, 5, 6. Okay? So from the center, like your circle, I'm going to go to the right 6 also. Let's look at B. Here's your B. B squared is equal to 121. And when you take a square root of that, so B is equal to 11. So from here, I'm going to go out 11. 1, 2, 3, 4. Notice it's under Y, so you're going to go up and down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'll put 11 there so I don't forget. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay? And there you have your elliptical shape. And there you connect it, just like that. All right. Now, I want to talk a little bit about the long axis. Do you see how long this is? This is your length of your axes, okay? This is called a major, but we're going to touch on that later. But I do want you, your homework asks you for the foci. The foci, not the foci, sorry, asks you for the vertices. The vertices is always on the long axis. So what are your vertices? So basically it's a point. What point is that? That is 0, 11. What point is this? 0, negative 11. Those are called vertices, okay? Now, do you see the shorter one? The shorter length? That is called your covertices. And what are the points for your covertices? Negative 6, 0, and 6, 0. And it's just a point. So it's like the furthest, your major, your vertices is like the furthest point from the center. Your covertices is the closest point to your center. Okay? All right, so let's look at example 3 right here. I guess I missed example 1. All right, that's all right. So let's go to example 3. So let me label. I'm going to use a pencil to label, okay? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Here's your X. All right. So what is your center? Your center is 0, 0. Okay. So I'm going to go to 0, 0. Now, A, square root of 4 is 2. B, square root of 25 is 5. So this is under X. So I'm going to go out to the left. 2, right 2. 5 up, 5 down. And there you have your ellipse. Okay? And let's go ahead and name our vertices. So what is your coordinate? What is the furthest point from that? 0, 5. The other side, 0, negative 5. And there you have your vertices. All right. Now, as with the graphs of functions and circles, the graph of ellipse may also shift, and it might shift, okay? As with the graph of functions and circles, the graph of an ellipse may also shift. It might shift horizontally, which will be your H, or it could shift vertically, which would be your K, okay? When this occurs, the top of the equation changes, okay? So the top of the equation changes. All right, so for example, here we go, example 2. Let me go ahead and label this. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. All right. So find your center. What's your center? Negative 4, 1. Just like a circle, remember it's opposite. So negative 4, positive 1. Okay? A is equal to square root of 16, so A is equal to 4. Okay? So it's under X, so I'm going to go left 4 from the center. So you're going to go 1, 2, 3, 4. 1, 2, 3, 4. Okay? Your B is equal to square root of 36, so B is equal to plus or minus 6. You don't have to write plus or minus because it's a distance. So from your center, I'm going to go up 6. 1, 2, 3, 4. Oops, that's crooked, so sorry. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay? And there you have your elliptical. Well, that looks terrible, but okay. All right, so how do you find your vertices? Well, this one is the longest axis. So what is your vertices? Well, it's at negative 4, okay, but notice the 1. All right? Okay, so it's under X. No, sorry, it's the Y. So 1 plus 6 is 7. 1 minus 6 is negative 5. Or you can do it this way. Just count. You're at 1, 2, 3, 4, 5, 6, 7. You're at 1, 0, negative 1, negative 2, negative 3, negative 4, negative 5. You can do it like that as well. So there's your vertices. All right, let's look at example 3. You guys try example 3. Pause right here, and then you check, okay? And then play again. All right, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, so here we go. Center is 2, negative 3. There's your center. So we're going to go to 2 and make it a little bit, okay? Positive 2, negative 3. Right there. All right, there's your center. Now, A is square root of 25, so A is plus or minus 5. It's under X, so I'm going to go 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay? And then here, maybe I should write it in pen. You can see it better. Here's your B. It's always under Y, so B is square root of 49, so B is equal to plus or minus 7. So from there, I'm going to go up 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay. And since my graph is not perfect, I want to use my counting to help me find my vertices. And there should always be 2 points. What's the 2 furthest point? Well, this one and this one. That's co. All you have to do is list the vertices. So what are those points? Well, it's at 2. And so it's, let me see, what is this? Negative 3, negative 2, negative 1, 0. 1, 2, 3, 4. So it's 2, 4. By the way, you know it's on the Y, so look at the Y. What's negative 3 plus 7? 4. Okay? Let's go down. Negative 4, 5, 6, 7, 8, 9, 10. Negative 10. What's negative 3 minus 7? Negative 10. 2 different ways you can do your math, okay? And there you have it. That's all I want today, is for you to graph and label your vertices. Not the co-vertices, just the vertices. Thank you, guys.